All right, talking about making an equation when given a table. So here we have a bunch of input-output tables, and we are going to make an equation just from the information that is set right here. First of all, we notice we have our input and our output. Very first thing that we have to decide is what is the input variable and what is the output variable. What is the input variable? What is the very first one going to be? X. I'm going to put that on my table so that I know that all of those values are my X values or my independent value. What about my output or my out? McKenna?
Y.
This is going to be my Y. So if you did not already do that, you need to do it now. Now that we know our variables, our X and our Y, our independent and our dependent, we're going to go ahead and say, what am I doing to my input or my X every single time to get to my output? What am I doing with X to get to my output every single time, Aiden?
+4.
I am adding 4. Now, I'm not just going to go by the very first one, because a lot of times the very first one could have a lot of different rules. But those rules may not happen to each and every one. So I said I'm going to add 4. Is 31 plus 4 35?
Yes.
Is 34 plus 4 38?
Yes.
Is 44 plus 4 48?
Yes.
46 plus 4, is it 50?
Yes.
47 plus 4, what is it?
51.
So every single time, what am I doing to my X value?
Adding 4.
And what does that give me?
X plus 4
X plus 4 equals
equals Y.
Y. So now, using this equation, I could give you any value for X, and you would be able to give me the Y value, correct? Yes?
Yes.
All right, let's look at number 2, input, output. Input will always be my X. Output is always dependent on your X value. What am I doing to my X, or my 21, to get to 15? Mason? Subtract 6. Does everybody agree?
Yes.
Does it happen with all of them? Does 24 minus 6, does it give me 18?
Yes.
Does 35 minus 6 give me 29?
Yes.
Does 40 minus 6 give me 34?
Yes.
54 minus 6, does it give me 48?
Yes.
So my rule to this input-output is X minus 6 equals
Y.
Y. Does everybody agree?
Yes.
Awesome. Okay. Go ahead and give me the equation or the rule for number 3. Raise your hand. Jeffrey.
The input is Y and the output is X.
Nope. Input is always X. Output is always Y. I want to know the rule or the equation.
That 17 to 13 is -4.
Okay, so what am I doing to X to get to Y?
-4.
Very good. So my equation is X minus 4 equals Y, because I'm subtracting 4 every single time. All right, what is my equation for number 4? Andrew.
Y equals X minus 10.
Y equals X, do what?
Minus 10.
Minus 10. Notice that he gave it to me with my Y equals first. Is that any different than up here? No, it's still the same thing, right? Yes?
Yes.
All right. What about number 5? Rainey?
Y equals X minus 15.
Y equals X minus 15. Does everybody agree?
Yes.
Number 6, Mason?
Y equals X plus 13.
Does everybody agree?
Yes.
X plus 13. All right, number 7, McKenna?
Y equals X plus 5.
Does everybody agree? 8, Aiden?
4
9. Clayton?
Y equals X minus 10.
Y equals
X minus 10.
Just like at the end of the class.
Number 10.
Okay. Okay.
Blaine?
Y equals X minus 15.
Minus 15. Does everybody agree?
Yes.
All right. 11. Vincent?
X equals X plus 15 equals Y.
Does everybody agree?
Yes.
All right. Number 12. Paige?
X plus 8 equals Y.
Does everybody agree? No? What do we not agree with?
Let's look on number 2.
Number 8. We want to come back up to number 8.
It has to be minus 13. No, plus 13. Yeah.
So 8 should be Y equals X plus 13?
Yes.
Very good. I like the way that you still brought it up as, wait a minute, that didn't seem right. Very good. Okay, now let me ask you something. Looking at all of these equations, we've looked at all of our input-output. What type of relationship is these? Are these additive or multiplicative? Mason? Additive relationships. Now, why are these all additive relationships when I've got some subtracting in here? Chloe?
Because there's additive relationship is because there can be adding or subtracting.
And adding and subtracting are considered to be what type of, are they an inverse relationships? Awesome. Okay, so how do we feel about this? Not too bad, right? All right, so what I'm going to do now is we're going to flip it over and we're going to go ahead and do the back.